Observe the barren Mars wasteland. Life has not existed here for ages, if at all. Breathtaking. Okay, we're on in 5, 4.
Good evening. I'm British reporter Trisha Takanawa. Tonight, going to be talking to you about the magnificence of the Mars rovers. Truly works of art in the machine world. The Mars rovers. Tonight at 11. NASA has given us the momentous sneak preview to see what the Mars rovers can do. Notice its agility and grace. Notice how it can overcome terrain, and when confronted with an obstacle, it can overcome most challenges. Notice how it bumped into the obstacle and went around. These are the advances of modern technology. And when it needs an object, it can pick it up at will. And when it wants, it can conserve energy by shutting down. The Mars rovers are works of machinery. There would be nothing if we couldn't get them to Mars. There are multiple steps to getting the Mars rovers to Mars. The first step is the pre-launch, which is the usual jibber-jabber of getting the fuel into the ship, finding the crew, and finding a place to launch off of. The second step is the launch, which is getting enough lift for the ship to escape the Earth's gravitational pull and go into space. The third step is the cruise, which is traveling the distance in between the Earth and the Mars planet. The fourth step is the approach. The fifth step is the entry, the landing, and the descent, which is all very self-explanatory. The next step is the rover egress, which we will get into later. And the final step is surface operations. After the first step, which is pre-launch activities, the next step is the launch itself, which is creating enough lift for the spaceship to make its way out of the gravitational pull of the Earth and make it into the vacuum of space. Now there are two rovers, Rover A and Rover B. Rover A is scheduled to depart on June 5th, 2003 and is expected to arrive to the Red Planet on January 4th, 2004. Rover B is expected to depart on June 5th, 2003 and is expected to arrive to the Red Planet on January 25th, 2004. Now the major activities of this mission include the initial liftoff and the boost phase of the launch, the insertion into a circular parking orbit, and a coasting period, followed by an additional launch boost to push the spacecraft into its trajectory towards Mars. And finally, the separation of the spacecraft from the launch vehicle in its trajectory. The third phase of this journey is the cruise, which is to travel from Earth through space to the planet Mars. Now the cruise phase begins soon after the separation of the Delta II, which is the spacecraft. During the cruise, the spacecraft will spin at 2 revolutions per minute and will maintain an antenna pointing towards Earth and the solar panels pointing towards the Sun. Now, due to a widespread separation between the Sun and the Earth, the spacecraft will use low gain antenna, a CLGA. used for the early cruise communications for the first couple of months of the cruise. As the Earth and the Sun come closer together, viewed from the spacecraft switches to a medium gain antenna for the remainder of the cruise. In short, the activities during this phase include the health check and maintenance of the spacecraft, the monitoring the calibration of the spacecraft subsystems, and altitude corrections turns, which, in short, spins the antenna towards Earth and the solar panels towards the Sun. And the navigation activities, which include trajectory, correction maneuvers, and correcting the vehicle's flight path. Now, you may be wondering why I'm wearing a tuxedo t-shirt and shorts. Now, the fourth step to this process is the approach. Now, to ensure a successful entry, descent, and landing, engineers must begin extensive preparations 45 days before the spacecraft enters the Martian atmosphere. During this phase of the preparation, they call it the approach phase. It lasts until the spacecraft enters the Martian atmosphere, which extends from 3,522.2 kilometers, 2,113 miles for you Americans, as measured from the center of the red planet. The mission team switches to Mars time during this phase. The Martian day, or SOL, is about 40 minutes longer than the Earth day, so the Martian team needs to synchronize their rovers to their schedule. The activities that the engineers focus on during the approach phase include the final 3 trajectory correction maneuvers, which are used to make the final adjustments to the spacecraft incoming trajectory towards Mars, altitude pointing updates as necessary for communications and power, the frequent delta DOR measurements that monitor the spacecraft's positions and ensure accurate delivery, the start of the entry, descending and landing behavior software, which automatically executes commands during that phase, entry, descent, and landing parameters updates, spacecraft activities leading up to the final turn to the entry altitude and separation from the cruise stage, the loading of the surface sequences and communication windows needed for the first several sols. Now, during the approach phase, the amount of requested tracking by the Deep Space Network is substantially increased to allow engineers to determine the more accurate trajectory solutions in the final weeks before their arrival at Mars. This tracking supports a safe delivery of the spacecraft to the surface of Mars. The Deep Space Network's 34-meter and 70-meter antennas are able to provide tracking coverage of the spacecrafts during the approach phase. Landing of the Mars rovers, from an aerial point of view, must look a little something like this. And a little while later, the second spacecraft will look a little something like this. Now, the fifth phase of this long process is the entry, the descent, and the landing, the EDL. Now, this phase begins when the spacecraft reaches the Mars atmospheric entry points at 3,522.2 kilometers for few Americans, 2,113 miles from the center of Mars, and ends when the lander is on the surface of Mars in a safe state. Now, the rovers will arrive later in the later half of the northern winter and the southern summer on Mars. Ironically, they will both land around the same afternoon. Now, the entry, descent, and landing sequence on the Mars Exploration Rover mission is an adaptation to the Mars Pathfinder method. Now, an aeroshield and a parachute decelerate the lander through the Martian atmosphere to slow it down so it doesn't hit the ground and go kajiblets. And prior to the surface impact, retro rockets are fired to slow the lander's speed to the descent of the airbags, and the inflation will cushion to slow down the impact, so it won't go kablibbles. Now, the airbags then deflated and retract, and the lander's pedals and the rover will egress, and the aids are deployed. Once the pedals have opened, the rover deploys its solar rays and places the system in a safe state. Now, the sixth phase of this process is called the rover egress. Now, this phase is defined as a period of time following the placement of the rover into the safe state on the Martian surface, and, after landing, driving the rover off the lander onto the Martian surface. Now, the egress phase will likely last 4 or 5 sols. The major deployment and the egress activities are power intensive and must occur during the Martian day when the solar rays can charge the rover battery. When the rover and the landing site are naturally illuminated, the actual rate of egress activities are largely dictated by the availability of power, the duration and number of ground decision points, and the availability of communication links. Now, the lander has no further function or capabilities after egress is complete, so there are no pictures taken of the rover himself during the operation. The pictures taken from the rover are much like those you would take in your car. You will see little bits and pieces of the rover in the picture, but you will not actually see the rover itself in the picture. Now, the egress phase consists of carefully choreographed series and steps, each initiated by the ground only after verification that the previous steps have been taken. Because there is limited knowledge of the terrain, before the rover arrives, the flight team must interactively access rover data and command the rover, then access the resulting data before proceeding to subsequent steps. Sorry about that, we had some technical difficulties with all this Martian atmosphere. Now, as I was saying, consequently, many possible egress scenarios exist, which means anything can happen. So, like the Cub Scouts say, always be prepared. And the principal steps of this phase include the deployment of the pan-cam mast and the high-gain antenna, the characterization of the lander, the landing site, and the surrounding terrain, the rover actually standing up, the calibration of scientific instruments, the selection of the suitable egress path, and the egress from the lander to the Martian surface. All rather intriguing. Now, all good things must come to an end, and the eventual end of this mission goes a little something like this. Now, toward the end of the surface phase for both missions, both power and telecom capabilities will be decreasing. As the Earth and the Sun become more distant from Mars, dust falls on the solar panels, the batteries lose capability, and the Sun moves farther north past the landing site latitude. Eventually, it expects that the rovers will be unable to store up enough thermal or battery energy to prevent its components from overnight temperatures from the falling below flight level capabilities. That will sooner or later result in the failure of one or more of these components, silencing the rover forever. Now, this is the Mars rover. Now, as the Sun becomes more distant from Mars, you will notice dust falling on the solar panels. Lots of dust. And it will soon lose battery capability, thus slowing it down. It will eventually keep slowing down until the battery is completely drained and it stops and keels over. Its mission here is done. It has sent all its information back home to Earth.